this episode, we bring the vulnerability management cycle into the action stage by looking at remediation, verification, and internal reporting. Finding and prioritizing vulnerabilities is important, but the organization does not become safer just because a report exists. Risk is reduced when people take action, confirm that the action worked, and communicate progress clearly enough for others to understand what changed. Remediation is the work done to fix or reduce the vulnerability. Verification is the process of proving that the vulnerability was actually fixed or that the risk was reduced as expected. Internal reporting keeps the right people informed about status, delays, exceptions, and remaining exposure. These steps are where vulnerability management becomes visible inside the organization. A security team can identify a serious weakness, but if no one patches it, changes the configuration, applies a compensating control, or makes a documented risk decision, the weakness remains part of the environment. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. Remediation begins with ownership and a clear decision about what action should happen next. A vulnerability finding should not sit in a report with no assigned owner, no due date, and no path to resolution. Someone needs to know which system is affected, what the weakness is, how serious it is, what business function depends on the asset, and what action is expected. Sometimes the owner is an infrastructure team. Sometimes it is an application team, cloud team, vendor manager, data owner, or business system owner. Clear assignment matters because vulnerability management often crosses team boundaries. The security team may discover the issue, but another group may need to make the change. Good remediation work also defines scope. If one server has a vulnerable version of software, the team should ask whether other systems have the same version. Fixing one visible example while leaving the same problem elsewhere can create false progress. Patching is one of the most common remediation actions because many vulnerabilities come from known flaws in software, firmware, operating systems, applications, libraries, or devices. A patch updates the affected component so the known weakness is corrected. Patching sounds simple, but real environments make it more complicated. Teams may need to test the patch, schedule downtime, confirm compatibility, notify users, backup systems, coordinate with vendors, and prepare rollback plans in case the update causes problems. Some systems are easy to update because they are modern and centrally managed. Other systems are fragile, legacy, specialized, or tied to business processes that cannot stop without planning. That does not mean patching can be ignored. It means the organization needs a managed patch process that balances urgency with stability. A critical internet-facing vulnerability may justify emergency patching, while a lower-risk internal issue may follow the normal maintenance schedule. Configuration changes are another major remediation method. Not every vulnerability is fixed by installing an update. Some weaknesses exist because a system, application, cloud resource, identity setting, or network control is configured unsafely. A storage location may be publicly accessible when it should be private. A firewall rule may allow more access than needed. An account policy may permit weak passwords. A cloud role may have excessive permissions. A database may expose a management interface to too many systems. Remediation in these cases means changing the setting so the exposure is reduced. Configuration remediation can be powerful because it may fix risk quickly without waiting for a vendor patch. It also requires care because configuration changes can affect access, application behavior, integrations, and user workflows. A good change should be documented, tested when appropriate, approved through the right process, and verified after implementation. Hardening is closely related to configuration remediation because it reduces the attack surface of a system. A remediation plan may call for disabling unnecessary services, removing unused accounts, closing unused ports, enforcing stronger authentication, enabling logging, restricting administrative access, or applying secure baseline settings. These actions may not be tied to one single software flaw. They reduce the number of ways a system can be attacked or misused. For example, A vulnerability scan may show that a server exposes several services that are not needed for its business role. Remediation may involve turning those services off and limiting network access to the ones that remain. This reduces future risk as well as current risk. Hardening also helps when a system cannot be patched immediately, because fewer exposed services and tighter access rules give attackers fewer opportunities while the organization works toward a permanent fix. Compensating controls are used when the preferred remediation cannot happen immediately or cannot happen at all in the normal way. A compensating control reduces risk around the weakness without fully removing the weakness itself. For example, a legacy system may have a known vulnerability, but the vendor may no longer provide patches. The organization might isolate the system on a restricted network, allow access only from specific management workstations, monitor it closely, remove internet access, and require stronger authentication around it. These actions do not make the legacy software safe in the same way a real patch would, but they reduce the chance of exploitation and limit the damage if something goes wrong. Compensating controls should be intentional and documented. They should not become a quiet excuse for leaving risk open forever. When possible, they should have review dates, owners, and a plan for eventual replacement or permanent remediation. Risk acceptance is different from remediation because the organization knowingly decides to tolerate a remaining risk rather than fix it immediately. This should never be casual or hidden. Risk acceptance should be approved by someone with the authority to accept the business consequences, not simply by the person who does not want to do the work. There are valid reasons risk may be accepted temporarily. A fix may be more disruptive than the risk during a critical business period. A system may be scheduled for retirement soon. A vulnerability may exist in a tightly isolated environment with strong compensating controls. A vendor may need time to provide a supported update. Even then, acceptance should include the reason, the affected assets, the expected duration, the business owner, the remaining exposure, and any monitoring or compensating controls in place. Accepted risk is still risk. It is just risk the organization has chosen to carry knowingly. Remediation also requires prioritizing the method, not just the finding. Two vulnerabilities may have the same severity label but need very different responses. One may be fixed by applying a routine update. Another may require an application code change, vendor coordination, database migration, or architecture redesign. A cloud misconfiguration may be corrected quickly through policy, while a legacy operating system may require replacement planning. Security teams should help owners understand the available options. The best answer is usually the one that reduces meaningful risk in a practical and sustainable way. A quick fix that breaks a business service may create new problems. A slow fix that leaves a critical exposure open for months may be unacceptable. Remediation planning should consider urgency, business impact, testing needs, maintenance windows, dependencies, rollback options, and whether a temporary control is needed before the permanent fix is complete. Verification proves that the remediation action actually worked. This is a crucial step because many fixes fail in quiet ways. A patch may appear to install, but not apply correctly. A system may need a reboot before the fix takes effect. A configuration change may be overwritten by automation. A firewall rule may be changed in one environment, but not another. A vulnerable library may be removed from one application component while remaining in another. A cloud setting may be corrected manually and then recreated incorrectly by a deployment template. Verification protects the organization from closing findings based only on good intentions. It asks for evidence. That evidence may come from a rescan, a configuration review, a version check, a code review, a retest, or logs showing that the risky behavior is now blocked. The method depends on the finding, but the principle is the same. Do not assume fixed means fixed. Rescanning is one of the most common verification methods in vulnerability management. After a patch, configuration change, or other remediation action is completed, the affected system can be scanned again to see whether the finding still appears. If the scanner no longer detects the vulnerability, that is useful evidence. If the finding remains, the team knows more work is needed. Rescanning can also reveal whether the same issue exists on related systems that were not included in the first fix. However, rescanning should be interpreted carefully. A clean scan is helpful, but it may not prove every part of the risk is gone. Some findings require manual validation, application testing, source code review, or cloud configuration review. A scanner may not understand a business logic issue or a compensating control. Rescanning is powerful, but it is part of verification, not the only possible proof. Verification should also confirm that remediation did not create a new problem. A patch may fix a vulnerability, but cause an application failure. A restrictive firewall change may reduce exposure, but block a legitimate integration. A stronger access policy may improve security, but lock out a service account that a business process depends on. A cloud permission change may reduce excessive privilege, but break an automated workflow. Security is not improved if the organization fixes one issue while creating an avoidable outage or unsafe workaround. This is why testing and communication matter. Before and after remediation, teams should know what success looks like. Does the application still work? Can approved users still access what they need? Are logs still being collected? Is monitoring still active? Has the risky access been removed? Strong verification checks both security outcome and operational outcome, so the organization can be confident in the change. Internal reporting keeps remediation work visible. Different audiences need different levels of detail. A technical team may need host names, affected versions, patch instructions, configuration details, and skin evidence. A system owner may need status, due dates, risk explanations, and business impact. Leadership may need trends, aging findings, critical open risks, accepted risks, overdue items, and whether the organization is improving. The goal is not to flood everyone with raw skin data. The goal is to give each audience the information needed to act. Good internal reporting shows what has been found, what has been fixed, what remains open, who owns it, why it matters, and what is blocking progress. It should also distinguish between remediated, verified, mitigated, accepted, and overdue. Those words matter because they describe different states. A finding that has a compensating control is not the same as one that has been permanently fixed. Status communication should be honest and plain. If a critical vulnerability remains open because a business system cannot be patched until the weekend, leaders should know the reason and the temporary controls in place. If a team is waiting on a vendor, that dependency should be visible. If a patch failed, the report should not pretend progress was completed. If risk was accepted, the responsible business owner and review date should be clear. Internal reporting is not about embarrassing teams. It is about making sure risk decisions are visible and owned. Clear reporting also helps security teams build trust. When reports are accurate, practical, and tied to real business impact, other teams are more likely to engage. When reports are confusing, alarmist, or full of unexplained technical language, people may tune them out. The best reporting helps people understand what action is needed and why it matters. Metrics can help internal reporting, but they need to be chosen carefully. A report may show how many critical findings are open, how many have been remediated, how many are overdue, how long findings remain open, which teams have recurring issues, and which asset groups carry the most risk. These numbers can reveal patterns. If one application repeatedly has the same kind of vulnerability, the organization may need better development practices. If one server group misses patches every month, the patch process may need improvement. If many findings remain open because of maintenance window delays, leadership may need to address scheduling constraints. At the same time, metrics can mislead if they reward the wrong behavior. Closing many low-risk findings may look productive, while a few serious issues remain open. Reporting should measure risk reduction, not just ticket movement. For security plus questions, match the action to the phase. If the scenario describes applying a patch, changing a setting, disabling a risky service, rotating a secret, or fixing code, think remediation. If the preferred fix cannot be applied and the organization uses segmentation, monitoring, access restriction, or another temporary safeguard, think compensating control. If the organization knowingly decides to tolerate the remaining risk with approval, think risk acceptance. If the scenario describes scanning again, retesting, checking versions, reviewing configuration, or confirming a fix, think verification. If it describes sharing progress, overdue items, ownership, status, trends, or remaining exposure with internal stakeholders, think internal reporting. The exam may give you several reasonable actions, so pay attention to what has already happened and what the organization needs next. The larger lesson is that vulnerability management only works when findings move through action, proof, and communication. Remediation reduces risk through patches, configuration changes, hardening, code fixes, compensating controls, or other corrective work. Risk acceptance documents the decision to carry remaining exposure when fixing it is not currently practical or justified. Verification confirms that the action worked and that the organization is not relying on assumptions. Rescanning provides important evidence, but some issues need deeper validation. Internal reporting keeps owners, technical teams, and leaders aligned on what is fixed, what is open, what is delayed, and what risk remains. These steps turn vulnerability management from a list of problems into a working process for reducing exposure. When you understand remediation, verification, and reporting together, you can see how security operations creates accountability after weaknesses are found.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.